Hello, today our topic so that we are going to detect the error in the received information as well as we'll able to do the correct the single bit also. So that is code is called as the Hamming code. So finally it is the error detection and single bit error correction. So here first of all to understand the Hamming codes we need to see the different situation. What are the possibilities are there? So suppose we are transmitting some information. Okay. So when information is transmitted, so finally this transmitted information, when we are going to get in the another side, that is the receiver. So in receiver, when we are going to get this information in the receiver side, so what are the probabilities there? So whatever is being transmitted will obtain without error. So this is the first possibility, without error. And second possibility is what? It has error. Okay, it has error. So now when we'll transmit the information, it has message bits plus parity bits. Okay, so when we are going to obtain the information, so in that generally parity bits will be corrupted. So we are going to see here how we'll decide that there is the error or not. So before that, we need to recognize how we are transmitting the information. Once we'll understand that, what are the combinations are there when we are going to transmit the information from one place to another place. So in that, important thing is parity bits. Apart from the message bit, we are going to add the parity bits. So now, how many parity bits are required? Do you have any idea? How many parity bits are required? So that number of parity bits depends upon the number of message bits. Okay. So for that we have a relation that is called as to the power p minus 1 should be greater and equal to p plus m, where p is the number of parity bits. Okay. And what about m? M is the number of message bits. How many message bits we are going to transmit. Now suppose for example, so this is the first step in this. We are going to decide how many parity bits are there. Now if we are taking M equal to 4, okay, we are going to transmit 4 message bits. So now what will be the value of P so that it should be greater than P plus N. So in that case, if you substitute, for example, p equal to 2. So what we'll get here? To the power 2 minus 1. So this value is how much? This is the left side, and right side what we'll get? Since we have taken p equal to 2 and message bit is 4. So finally, if you see here, to the power 2 is 4 minus 1 is 3. And here we have 6. This is not valid, am I right? 3 is not greater than 6. So now what we'll do, we'll take the another value of p. Now here we have taken p equal to 2. Now we'll take p equal to 3. So in that situation, we have to the power 3 minus 1 should be greater and equal to. Now parity bit is 3, so 3 plus message bits are 4. So now if we check here, to the power 3 is 8 minus 1 is 7. So this 7 is what? At least greater, it's not greater means at least it is the equal to the 7. So this is the true. So finally, from this what we understand that to transmit the 4 message bits, we required how many parity bits here? We required 3 parity bits. Okay, number of parity bits are how many? 3 are required. So once we have this type of the information that we have 3 parity bits. So what will be the next step is that what is the position of the parity bits? At which position we are going to place the parity bits? So that position of the parity bits is decided on the basis of to the power n. So since here number of parity bits is 3, okay. So this n value will be 0, 1, 2. So when we have n equal to 0, so from here n equal to 0, what will get here? To the power 0, that is the 1. So that means first parity bit P1 will be where? In first position. When n equal to 1, we have to the power 1, that is the 2. So parity bit, second parity bit will be in the second position. Next we are taking n equal to 2. So to the power 2 is what? 4. So third parity bit will be where? In the fourth position. So like this parity bits we are writing as the P1, P2, P4 and their positions. This showing their corresponding, this subscript is showing their corresponding position also. P1, P2, P4. Apart from this, we have 4 message bits. Okay. So 4 plus 3, total 7 bits will be transmitted. So now we will take one example. For that particular example, we are going to see that what will be the location of the parity bits, how we are going to represent. From here, you understood that how we are deciding that how many parity bits are required. And next, you are going to decide what will be the position of the parity bits. Okay. Now we are taking one example in that. Suppose we are taking the message bits, 4 message bits. Okay. So M is here, message. So we can write message bits. So 4 message bits, suppose we are taking 0, 1, 1, 0. So this message bits, here we can write fourth one is this one is the M1, this is M2, M3, and last one is M4. Now, since here we have 4 message bits, so number of parity bits will be how many? How many parity bits? Tell me. How many? 3. Okay. So 4 plus 3, total 7 position will be there. So that's 7 position. 1, 2, 3, 4, 5, 6, 7. Here I am writing position from the left to right. Okay. You can consider from the right to left also. So how you are going to consider on the basis of that remaining discussion will going to depend on that. So here I am considering counting from the left to right. So here this is the already we have seen this is the position of first parity bit. This is the position of the second parity bit and third position is here P4, that is third parity bits. So this position of the parity bit is recognized by the to the power n. Okay. So since here n is 3, so that n value is going to be here 0, 1, 2. On the basis of this position of parity bits are here. Next, what will be the remaining position will be for the message bits? This is M1, this is the M2, this is the M3, and this is the M4. So now, if you see that here, we can write whatever message bits are given that we can locate here. So what we have 0. Next we have here 1 and this is the 1 and this is the 0. Now we have to decide what will be the value of the parity bits. Okay. Randomly we can't write parity bits as the 0 or 1. So for that we need to decide what will be the value of the parity bits. So that is the third steps. You are going to recognize, you are going to find the value of parity bits. So now when we'll talk about the parity bits value, so here we have two concepts. Either you can consider even parity or odd parity. So in the question, generally it will be given either you have to follow even parity or odd parity. Okay. So these things you have to keep in mind that for the parity bit 1, okay, what are the position we are going to consider, that you have to keep in mind. So parity bit 1, for that we have to consider the position 3. We have to give one gap. 1, 2 is gap, 3 we are writing, 4 is gap, 5 we are writing, 6 is the gap. Okay. Next what will come? 7. If more number of bits are there, next will come 9. So similarly for the P2, second parity bit, that position is P2. So for that, we'll start from the 2 here. So it's second parity bit, so 2 will take together 2 position. So what will here? 2 is already there. So what will write 3. Next 4, 5 is gap. Okay. Next what will have? 6, 7. So for the second parity bits, 2 gaps we are giving. Next is the fourth, that is third parity bit, that is the P4. So again here we'll start at 4 and we'll take the 4 uh, consecutive ones. So after 4 what we have? 5, 6, 7. Okay. These things is going to help us when we are going to correct the error also. This combination will help us. So now here we are considering which concept? Even parity. So in case of even parity, so when we look for these positions, if number of ones are even, then parity with value will be 0. If number of ones are not even, then we have to make it even by adding the 1. Okay. So let us, for example, so even parity bits means number of ones should be even, whatever combination we are going to look. So in that case, now suppose we'll look for the P1. So to find the P1, what are the position we have to look? Third position. Third position is what here? 0. What is the fifth position? 5. What is the next seventh position? Is 0. So here we can apply the XOR gate concept also, or simply if you are going to add also. So here, since you know that XOR get is going to represent the odd function, okay, that discussion will be later. So now here generally is a simple way you think that here 0 plus 1 plus 0. If you do the sum also, we are going to get 1. And here number of ones are how many? So here number of ones is what? It is the odd. So how we'll make this number of ones as the even means you have to add 1 here. Okay, so which bit we can add? We can change the parity bits. So parity bits are only in our hand. Okay, so that's why the parity bit value will be here 1. Okay, so this P1 is going to be the 1, so that we'll have even parity. So this P1 we are writing as the 1. Next you'll check for the P2. So for the P2 position 3, 6, 7. So third position is 0, sixth position is 1, seventh position is what? 0. So in that case, again, if you see that number of ones are odd, so we have to add one more 1. Okay, so again, P2 also going to be the 1. Parity with 3, that we have to look the position 5, 6, 7. So 5 is 1, 6 is 1, 7 is 0. So here number of ones is already even. Okay. So here no need to add 1 extra. So that parity bit, that is the third parity bit, position is 4. So we are writing P4. Value should be 0. So P1 already is what? 1 we have got. P4 should be what? 0. So that means the information what we are going to transmit here, that is the 1 1 0 0 1 1 0. Now in this, if you are going to receive the same information in the receiver section, means there is no error. But if it is going to change, any of the bit is going to change, then there is the error. So now first we are going to see that how we'll detect the errors. Okay. So to detection the errors, okay, so first we'll have detection and correction together. We'll see. So for that, we are going to consider the different combinations. So same for the same examples. Okay, suppose in this we are going to generate the error, and we are this 0 we are going to replace as 1. So for example, then our received information will be what? 11011110. So later we'll see that whether we are able to find this error or not, that we are going to see. So that will be called as the error detection and correction. So now we are going to detect the errors. Okay. So detection. So far you have seen what will be, how many parity bits will be there. Next we have seen what will be the position of the parity bits. Third, we have seen what will be the value of the parity bits. Fourth one is how we are going to detect the parity bits. Okay. So for that, we are going to consider one table. So that will be easy for explanation as well as for understanding purpose. So this is the C1, this is C2, and next what we are C4. So that we are writing again on the basis of like how we have written parity bits, on the basis of that only we are writing here. So since here we have three parity bits are there, so that's why we have taken three correction bits also. Okay. So with the help of three correction bits, what are the combinations are possible? So we'll have total how many combinations? Seven combination or eight. How many? Eight. So that will go 0 to 7. So that combination we are writing quickly here so that further we can analyze. So total how many combinations with the help of 3 bits? To the power 3 is what? How much? Tell quickly. So total how many? 8 combination. To the power is what? 8. So in this case, if you see that, if you are going to get letter C4, C2, C1 as the 000 means we are not going to get any error. Okay. If any of this C1, C2, 4 is going to be 1 means it has error. So for this combination, no error. Now for this, if you are going to see means 001 is the 1. So like this combination we are going to get means in the first bit we have error. So means at first position we have error. Similarly here, if you are going to get combination of C4, C2, C1 like this, then we have second bit having error. Second bit will have error. Like this, we can go up to last one. So here we'll have third bit has error. If you are getting the combination like this means fourth bit having error. Combination like this means fifth bit having error. And for this combination, sixth. And finally, this is going to show that seventh bit having error. So finally, how we have written for the P1, similarly, we have to look for the C1, C2, C4 also. So for the C1, what are the combination we are going to check here? Okay, so for the C1, you have to look the positions. Okay, so that position we have to, like how we have written in case of parity bits. So for the C1 again, we have to look for the 1, 3, 5, 7. 1 gap is here. For this C2, you will start with 2. Then what we'll have here? 3. Again 2 gap, 4, 5. Then we have 6, 7. Similarly for this C4, we'll start at 4. And we have consecutive 4 here. Bits, so 4, 5, 6, 7. So these bits we are going to look to check that whether it has error or not. Okay. And if you have C4, C2, C1 combination as the 000 means there is the no error. If any one of them is 1, at least any single correction bit should be 1 here, then we'll understand that it has error. So on the basis of that, what we have considered earlier, so in that situation, if you see that our received bit is, we have introduced the error in the fourth bit. So that combination is like this, what we have considered earlier, total seventh bit here. So now in this again, we have to mark the position. Okay. So in the exam, generally, they will give you the received information. In that received information, you have to check whether error is there or not. If error is there, then we have to go for the correction. Okay. The Hamming code is able to correct 1 bit error. So that is important. So in the exam, they will write it has how many message bits. So that message bit's position you have to recognize, since you know that how to find the position of the parity bits. Okay. So what are the parity bit positions here? This is the parity bit position. Okay. And remaining is what our message bit position. So this one is our M1. This is M2, M3, and this is the M4. So earlier we have seen that we have introduced the error here, okay, in the fourth bit. So that we are going to see whether we'll able to find. So whenever you do the numbering from left to right means always you do the numbering from the left to right. Otherwise you can choose the numbering from the right to left. So as per that again parity bit position will change, okay. And then you can reverse the message bit numbering also from the right to left, M1, M2, M3, M4 like this. So now here, if you see that, what is the C1 value? So for the C1, we have to check the first position. First position is 1. Second position is what here? Bit is 0. Not second. Second, we are not taking them, right? After first, next is third. So third bit is what? 0. Fifth one is, what's fifth bit? It is the 1. What is the seventh bit? It is 0. So finally 1 plus 1, this is means how many ones are here? Even. Okay, that means 0. So in the receiver also we are going to check the even parity. Okay, here always. So in the question it will be written. You are looking for even parity or odd parity. Now we'll look for the C2. For the C2, what are the position? 2 second position, that is the 1. Third position, we have 0. Sixth position bit is 1. And seventh position bit is what? 0. So again, if you see that number of ones is even here, so we'll write here 0. Next for the C4, we are going to check fourth, fifth, sixth, seventh position. So fourth is 1. Fifth is 1, sixth is 1, seventh is 0. So finally, number of ones is what here? It is not even, right? So if you so that's why if you add 1, then only it's going to be even. So this will be 1 here. So finally, C4, C2, C1 combination, what we are getting here? 1, 0, 0. So 100 means at least one number is 1 here, one bit is 1. So this is equivalent to what? 4. Decimal equivalent is 4. So that means fourth bit has error. So fourth bit had error means now we have detected. Okay. So we are able to detect the error. Detected error. Now next will be what? Correction. Correction is the last step. Okay. After detection, last step is what? Correction. So for the correction, what we are going to check? We are going to check the fourth position bit. So now fourth position bit, here we are going to check. So fourth position bit is what here? 1. So since it is 1, it is the error. So this 1 will be changed to the 0. Okay. So 1 will be corrected to the 0. So finally, received information in the after the correction should be 1 1 0 0 1 1 0, which is same as the transmitted information. Okay. Both received and transmitted become same. So like this, we are able to correct the error. First, we need to detect. So here main 5 steps you need to follow. First one is how many parity bits are there? What is the position of the parity bits? And third is what will be the value of the parity bits? So that value depends upon we are going to consider even parity or odd parity. Fourth is the detection of the error. And fifth one is the correction. So in the detection of the errors, this table you have to keep in mind. No need to draw in the exam, but you need to understand how we are going to calculate. So here C4, C2, C1, we have to write in this format. And here we are considering the even parity. So we have to count the number of ones. If it is not even number of ones, it will become 1. If we have already even number of ones, it will become 0. Same thing we are seeing in the parity bit value as well as in the correction also. Like this we are able to do. So if you feel it is going to be useful for you, so please like and share with your friends and subscribe also. And in this description, we have a link of the notes also. That PDF notes you can download from that link. Okay. Thank you. Thank you very much.